Mobilization of PFAS from heterogeneous soils, desorption by alcohol, Bio-Polymer Mixture. Sorry.
Ali, can you share your screen, please?
Yes.
Yes, we've got it. So you can.
I cannot share my screen because you already did.
No, it's okay. You can go. You
can start.
Okay. So good afternoon. Good afternoon, everyone. I am Ali Batikh. Today, I'm going to present you mobilization of PFAS from heterogeneous soils, desorption by alcohol biopolymer mixture. So this presentation is in framework of Promises project. So with this study, I'm going to explore. We explore how to desorb PFAS from heterogeneous soil using a novel biopolymer alcohol mixture. This technology holds a promise for effective soil remediation and contributing to the goals of European Green Deal. Next slide, please. So let's have a look to the aspect of this technology. So first of all, as you see, we have the PFAS soil remediation technologies as they are presented in this graph and listed based on their stage of development and range of practicality. And as you can see with me, that soil flushing method is one of the best according to its high feasibility and cost effective as mature scale. So the formulations that we proposed for this technology is a mixture between ethanol 50% volume fraction with a non-Newtonian fluid xanthine. So our choice was based first on previous studies that demonstrated the effectiveness of ethanol at 50% volume fraction in the regeneration of a granular activated carbon already contaminated by PFAS. First of all, and second, due to the capacity or the advantage that the non-Newtonian fluid shows in the heterogeneous soil in two-layer system, as it has the capacity to change its viscosity function of the permeability of the zone, as it shows in these experimental photos. Next slide, please. So what are the objectives of our study? First of all, is to demonstrate what is the effect of the ethanol 50% on the non-Newtonian behavior of the xanthine gum solution. And second, to see the effect of xanthine gum solution on the ethanol 50% desorption rate or percentage. Next, please. So in order to that, different experimental method was carried out. So first of all, in order to characterize the fluid and selected, a rheological experiment was made for the formulation proposed using a rotational rheometer. Then a batch experiment was made for a mixture of PFAS included PFOS, PFOA, PFHXS, and PABS at a concentration of 5 mg per liter on a soil composed of 92% of sand, 5% of clay, and 3% of organic matter. Then once the fluid was selected, a desorption experiment on the 1D column experiment was carried out for the same mixture of PFAS on the same soil which has a pore volume 150 milliliter, a porosity of 39%, and a permeability of 93 times 10 to power minus 12 meter square. Next, please. So let's begin first with the rheological behavior or behavior of the formulation proposed. So this is a graph represent in front of you the different the variation of different values of viscosity in Pascal second in function of the shear rates for different formulation proposed, which are xanthine gum 0.5 gram per liter, xanthine gum 1 gram per liter, and xanthine gum 2 gram per liter without and with ethanol. And as you can see with me in these behaviors, that adding ethanol to the xanthine gum solution, whatever the concentration of xanthine gum used, they didn't alter the non-Newtonian behavior, which means that we can see always that this viscosity is decreasing under increasing the shear rate or applying the shear rates. Second, next, please. So this is the first of all. So The first objective was to see what is the effect of ethanol on the 50% of ethanol on the non-Newtonian behavior of xanthigam, and we demonstrated that there is no effect of the ethanol. Second, what is the effect of xanthigam or the non-Newtonian effect of xanthigam on the desorption rate obtained by ethanol? So in this graph, this histogram represents the absorption percentage for different PFAS function of time. And as you can see with me that within the first 30 minutes, the PFAS exhibits the maximum absorption percentage. And the PFAS in yellow represents the highest absorption percentage, which 56%, because it has the lower solubility in water and the highest local W, or the hydrophobicity, let's say hydrophobicity local, 5.26. By comparing PFOA to PFAS, we can see that we have a slight difference in their absorption percentage, which is due to their slight difference in local W. And PFBS has the lowest absorption percentage, which is 2% according to its higher solubility in water, which is 46.2 gram per liter. This absorption percent, the results was followed by desorption results obtained for the same PFAS, but using different solution, which was ethanol 50% by xanthigam at 1 and 2 and 4 gram per liter concentration, and ethanol 50% and water. And as you can see with me that ethanol 50% could remove more than 95% of different PFAS, and adding 3%, adding xanthigam to the ethanol solution, an enhancement by 3% of desorption was observed. Next, please. So, as we can demonstrate that an improved desorption of PFAS in the presence of xanthigam independent of the concentration of xanthigam used. Second, and the conservation of the non-Newtonian behavior of xanthigam in the presence of ethanol. So the formulation proposed that will be tested in one decolor experiment is the mixture of ethanol plus polymer at a concentration of xanthigam at 0.5 gram per liter. Why? First of all, because it gives us a sufficient injection pressure in our porous media. Second, taking into account economic aspects. Next, please. So let's begin by the results obtained by one decolor experiment. So this histogram represents in front of you the different breakthrough curve for PFOS obtained after flushing with different flushing solution. In blue, it's representing the mixture of ethanol polymers that we proposed. In red, the ethanol 50% itself, and in green, the pure water. So as you can see, the first 4.5 per volume was about sorption. It means that we injected PFAS in this time. And then another 5 to 6 per volume was switched by the injection of different flushing solution. So first of all, the sorption obtained for PFAS for different columns was 89%. And so let's begin to discuss about the results. So PFAS elution ethanol, which is the blue, and the blue and red, ethanol with and without xanthigam was faster than water by 0.3 per volume, which indicating that the solubility of PFAS in ethanol 50% is higher than water. Second, the intensity of peak corresponding to xanthan ethanol is 30% higher than ethanol. As you can see, the peaks, the highest value of concentration C over C0 obtained by in blue and red, which means that we have a stable displacement. And the ethanol xanthigam mixture improved PFAS desorption by 10%. And as you can see in the total removal percentage in this diagram, we can see that PFAS recovery was obtained in water by 68%, enhanced to 84% after adding 50% of ethanol to this aqueous phase solution. And by adding only 0.5 gram per liter of xanthigam to this solution, 50% ethanol, the desorption rate or desorption percentage of PFAS was increased by almost 10% to reach 93%. Next, please. So same trend was obtained for PFOA as its elution in ethanol and ethanol polymer was faster by 0.8 per volume more than water, which indicating also that the PFOA solubility in ethanol was enhanced in presence of ethanol in compared to one in water. And also the intensity of P corresponding to xanthan ethanol is higher 40% than the one obtained by ethanol itself. It's also, which means that we obtained a stable front displacement. And by comparing the removal rates obtained for PFOA, we can see that in pure water, we had 80% of PFOA removed. Adding 50% of ethanol, we enhanced to 93%, and adding 0.5 gram per liter of xanthan to this solution, we reach almost 99% of removal rate of PFOA. Thanks. Next, please. Thank you. Same trend was obtained also for PFAS success. As always, we have an elution in ethanol with and without xanthan gum faster than water by 0.25 per volume, indicating that solubility in ethanol was enhanced more than water. The intensity of P corresponding to xanthan ethanol is 15% higher than the ethanol due to the stable displacement obtained by the presence of polymer. And by comparing the removal percentage obtained for PFAS success, we can see that PFAS success was removed by 70% after flushing by water. Adding 50% of ethanol to this aqueous solution, we increased by 15% to reach 85%, and 12% of enhancement in desorption percentage of PFAS success was obtained to reach 97% after adding 0.5 gram per liter to the ethanol solution of xanthan. Next, please. So in the case of PFBS, we saw that the PFBS solution in ethanol with and without xanthan gum was faster than water by 0.05 PV, which indicating that the PFBS solubility in ethanol was more or less comparable to the one of water. And we confirm that in the results obtained as water, as PFBS was removed by 89% by water, increasing by 5% to reach in the presence of ethanol, and enhance adding of xanthan enhanced a little bit the desorption of PFBS by 3% to reach 98%. Next, please. So before concluding, I would like to highlight that a model was developed on the using Langmuir method to the absorption of PFAS, and also another model was developed to fit the experimental results in the breakthrough curve for the non-Newtonian behavior for polymer for different PFAS compound. And also this study was submitted as an article in a hazardous material journal, and it was accepted fortunately, and in the few weeks will be online. So in conclusion, I would like to what we learned, that ethanol 50% didn't affect the non-Newtonian behavior of xanthan gum. The batch experiment shows that PFAS sorption depends on the chain length and functional groups. Batch desorption shows that xanthan gum ethanol mixture enhanced PFAS desorption regardless of the concentration of xanthan gum used. Current experiment demonstrated the enhancement of PFAS desorption after adding xanthan gum to ethanol. And I put it you a table summarizing all the recovery percentage obtained for each PFAS in one decolor experiment. And as you can see with me, that always the highest recovery percent obtained was with the formulation proposed, which is ethanol plus polymer at 0.5 gram per liter. Thank you for your attention. I'm happy to answer any question if you may have.